Hello. Today we are going to construct congruent angles, an angle that will be the exact same to one that we already have. What we have here are two separate angles, one acute and one obtuse, and there's a reason for that. I'll get into that in just a second. Now, like I said, today we're going to construct a congruent angle. We are going to draw an angle that is the exact same measure as the one that was provided. So what we're going to do is we're going to start with just this acute angle over here, and we're going to construct one that is congruent to it. So let's see. We're going to start off by just drawing a line. Doesn't matter where, straight line of some sort. What this line is just going to be one side of our angle, and we're going to draw it thick so we can see it, and that is going to be one of the legs, if you will, of our angle, one of the two rays. How about that? All right, here's what we're going to do. After we've used our straight edge to draw a straight line, we're going to bust out our compass. We're going to go to the angle that we've already been given, so this one over here. I'll put the non-pencil end on the vertex of my angle, and my compass will be to a width that is just of some it doesn't really matter how big it is right now. I just want to make sure that when I draw an arc, and I will draw an arc with the non-pencil end on the vertex, and I'll draw an arc through both rays of the angle. I just want to make sure I can see it and that it goes through the angle. As I do that, all right, I've got this arc. Sweet deal. Without moving the width of my compass, I'm going to go to the line that I drew. Put the non-pencil end on the far left side and draw a similar arc. I'm hoping that looks like this will be big enough. Looks like that'll be fine. Now, why are we doing this? Well, we remember that when we construct congruent segments, that a compass is an excellent measurement of distance. Well, here's why we did that. What I'm going to do is I'm going to extend my compass now that I've got both arcs. I'm going to make it the width from the vertex of my original angle to where that arc I just drew crossed the bottom ray, which means I'm going to do this. I'm going to extend my compass to that distance and that distance. All right, so that is the length of, let's say, the bottom portion from the vertex to the bottom portion where my arc crosses my leg. I'm going to go down here. This should be the same. Okay, got a check there. Sweet. Good. I did that for a measurement check for pretty much no other reason. But I do know that the distance from here to here is the same as from here to here. That's why we drew this arc. I'm going to use a similar technique, and that is I'm going to now extend my compass from back to my original angle, from where the arc crosses now both legs. So there. So again, good measurement of distance. That distance right there is going to be the same as distance as on this angle where the arc would cross both legs. But where is that? Well, here's how we find out. You put the non-pencil in here, and if it's spread to the correct distance, it looks like it might be a little short. There we go. I'm just going back to my original one. You do not have to do this. And I'm showing that, oh, okay, if I were to draw kind of an X here, or crisscrossing arcs, that would be at the location where the ray of my initial angle crosses my arc. Well, I just do that down over here. I move the non-pencil end down to the bottom, draw a crisscrossing arc. And that X right there, if I draw a straight line from that X to the vertex, I've now created two angles that are congruent. Now, awesome. Why do I have this obtuse one here? Because I always get the question, well, wait a minute, does this work if I have an obtuse angle too? Yeah. This is my bottom angle. Excuse me, bottom ray. My compass is to whatever width, but it will cross both legs. Draw there, draw here. Cool. And now we extend. Looks about right. Crisscross and arcs. Intersection. Not too shabby.